All right, this is the Chapter 2 practice test. Couple things before we start this. First off, make sure you realize you'll be able to use that cheat sheet with the transformations and a formula sheet that has the linear formulas on it. If you want to see exactly what you're going to be able to use, that is posted on Google Classroom as well, so you can see that, and that's what you'll get on test day to use. The other thing is I realize that this is a very intimidating practice test, and the test is similar to this, exactly the same. So it's a very intimidating test because it's so long. I know that it's 6 pages and I know that it's like 50 questions, but here's the deal. First off, to make you feel better, there's probably like 15-ish questions that are going to be multiple choice. So hopefully those don't take as long. And then once you get into the last 3 sections we did in this chapter, section 4, 5, and 6, those are all the transformations, and so there's not very much math in those. So I'm not saying it's easy, but it's not like you don't have to solve a lot of problems, and so those problems shouldn't take very long to say, go 3 units right, 4 units up, and reflect across the x-axis. So I know this is a longer one, but a lot of these questions shouldn't take too long, or else I'm hoping that it won't take too long. So that said, I'm going to walk through this question by question. Again, the best way to do this is the same thing I say with worksheets, where if you haven't done so already, I would stop this video. I would do every single one of these on your own. Then I would check the answers with the answer key that's on Google Classroom. And every one of them you got wrong, then come back and watch this video and just fast forward to those questions. That way you don't have to waste your time and watch every single question when you know how to do a lot of them. But that's going to be the best way to do this, and I think that's going to give you a really good idea of what you know and what you need to know, and then hopefully the stuff you need to know you can learn from this video. Okay, so let's go ahead and get started. So the first one, find the slope of the line through these 2 points. So that we're using the formula y2 minus y1 over x2 minus x1. So this is my x1 and y1. This is my x2 and y2. So this formula, I'm trying to not be too sloppy here, is -4 minus 3 over -6 minus -2. So when you solve this, again, I would just use a calculator, but -4 minus 3 is -7. -6 minus -2, that means it's a plus, so -6 plus 2 is -4. So that reduces down to +7 over +4. The next one, number 2, what kind of, a slope of 0 is what kind of line? And this is the kind of question I was talking about, where there's a lot of questions, again, not exactly like this, but they take the same amount of time, where this one, you just have to make sure you study it. You just have to know that if it is a slope of 0, that is a horizontal line. Oh. So number 3, the opposite, an undefined slope is what kind of line? This is a vertical line. So again, these 2 don't take very long if you study and if you know the answers. And again, there's going to be a lot of those later with the transformations, where if you study, they're not going to take too long. Find the slope of this line. So the way we did this a lot, so it's in standard form. That's my A, B, and C. So the slope is -a over b. So that's -2 over -5, which is 2 over 5. Now the other way you can do this is you could solve this and put this in slope-intercept form. So 2x minus 5y is equal to 10. Subtract the 2x from both sides. -5y is equal to -2x plus 10. Then when you divide everything by -5, surprise, surprise, we get -2 over 5, which is what we had here, which reduces down to 2 over 5. So there's 2 ways to do that when you're looking for the slope. Number 5, what is the slope of a line parallel to this? Again, just knowing vocab. Parallel means it's the same slope. So the slope of our line that I'm looking for is just 2 over 3. So again, I didn't do any solving. I didn't do any math. I didn't do any canceling. I didn't have to do any of that complicated stuff or any of that mathy stuff. You just have to make sure you study and you know those rules. Same thing, perpendicular over here. It's the opposite reciprocal. So if this is positive 2 over 3, the opposite reciprocal is negative, and then 3 over 2. Same thing, super quick one, doesn't take very long as long as you know those rules. Number 7, write the equation of a vertical line through this ordered pair. Well, again, a vertical line is going to be x is equal to some number. Again, you're just going to have to memorize that. There's a couple different ways you can do it, but at a certain point, you can, like, this is a good chapter. You could actually make flashcards and you quiz each other and stuff. This is a chapter you can actually, like, study for just like you study for history or science or something like that. So vertical line is x is equal to a number. That x is going to be the x value of your coordinates. So x is equal to -4. Write the equation of a horizontal line through this one. Again, horizontal is y is equal to, and then it's just y is equal to your y coordinate of that. So y is equal to -1. Number 9, write the equation of a line that is parallel to x is equal to 7. So it's parallel to a vertical line. Well, if it's parallel to a vertical line, then that means the line I'm finding is also vertical. And I put this on my answer key, but if you're looking for parallel lines, vertical lines are always parallel to vertical lines, horizontal lines are always parallel to horizontal lines. So if I'm looking for a vertical line, just like the one we did, that's going to be x is equal to, and it's just going to be x is equal to that point. Number 10 is the opposite. It's perpendicular. I didn't realize. No, oh, good. Perpendicular to y is equal to -5. So again, now it's perpendicular to a horizontal line. Well, if we have a horizontal line, what line is going to be perpendicular? That's got to be a vertical line. So now we're dealing with x is equal to for our answer. And again, it's got to be that x value for that. Anytime you have x is equal, you always do the x value. Anytime it's y is equal to, it's going to be the y value. Number 11, find the vertex of the following. Remember, there's a couple ways to think of this. The way I like to think of it, just because we've done it a lot lately, the vertex is, we start at 0, 0, so we went to the right 4 and then up 12. So if we go to the right 4 and then up 12, that ordered pair is 4, 12. That's the way I like to think about it. The other way to think about it is it's the negative of the opposite of this answer. So +4 is your x, and then this is your y, +4, 12. Either way works. Now the next one, what's the axis of symmetry? Now make sure you realize it is the same exact equation. So we already have the vertex, but if you didn't, that's honestly the first thing I would find. You don't have to, but I would find the vertex first, and then I know that the axis of symmetry is the x value of that vertex. And again, the axis of symmetry is always a vertical line, so you have to have x is equal to something. If you don't, if you just have axis of symmetry is 4, or even axis of symmetry is equal to 4, that's not right. That's not what I'm looking for. It's got to be x is equal to, because that axis of symmetry is a vertical line. Number 13, write the equation of a line in slope-intercept form with a slope of -3/4 and goes through this point. So this is one that we have two different ways of doing it. The way I've been showing you guys is point slope form. So y minus y1 is equal to x, is equal to m times x minus x1. So I have y minus my y1 is -3 is equal to my slope, -3/4 times x minus, x1 is 8. And then we start solving this. So I take the 4, this is plus now, to the left, the -3 to the right. So I have 4y plus 12 is equal to -3x plus 24. And now we're solving for y. So subtract 12. We have 4y is equal to -3x plus 12. Divide everything by 4. We end up getting y is equal to -3/4x plus 3. Now, obviously, this is a problem that you do have some solving, so this one takes a little bit longer, but again, we don't have a whole bunch of these types of problems. I guess I'd say less than half of them are problems that you have to do a lot of work like this. Now, that's one way to do it. The other way that I know a lot of you guys have done in the past is to use the slope-intercept form. And so the way you're going to solve this is you're finding the y-intercept because we know the slope. So if you find the y-intercept, then we have slope-intercept form. But to find the y-intercept, we need to plug this in for my y, -3. My slope is -3/4 times my x is 8, this number. And then we're going to solve this for b. So -3/4 times 8. Again, if you do it this way, hopefully you know how to do it, how to do these multiplications with fractions. You can use a calculator if you need to. If you don't know how to do this at this point, if you don't know how to multiply those fractions, I would definitely do it this way. And that's one of the reasons I like point slope form best. But again, you can use a calculator. So if you know how to put it in your calculator, by all means, do it this way is fine. So -3/4 times 8 ends up being -6. Add 6 to both sides. You end up getting 3 is equal to b. So now we have our y-intercept, so we can plug it back into slope-intercept form. We know our slope was -3/4x and then +3. So again, you can see that it gets you the same answer. Again, in my opinion, it all comes down to if you know how to do this fraction, whether you know how to do it by hand or in a calculator, doesn't make any difference. But if you know how to do that fraction, you can do it that second way. But if you're not sure, I would definitely stick with point slope form. Now, I apologize, number 14 is worded differently on yours because I forgot to put this last sentence in there, but hopefully you kind of get the picture because we've done a couple of these in class. If your cell phone is 20 cents per minute plus a $30 fee per month, express the scenario in slope-intercept form using m for minutes and c for cost. So that's a big thing. I want m for minutes and c for cost. So remember, slope-intercept form, the y value of your slope-intercept form is the total. So the total is the cost. That's the total amount you're spending. Then the slope is always the variable. So the slope is what you're multiplying by your x value. So you don't know what that is, or it depends on how many minutes you use, is a better way to say it. So if you do 1 minute, whoops, forgot, I need to label that as m. So 1 minute is 20 cents. That's not too expensive. But if you do 1,000 minutes, then you're getting a little bit more expensive. So that's the variable. That's what changes. It depends on how many minutes you talk. That's what makes your total cost go up or down. Because of this $30 fee, it doesn't matter whether you talk 1 minute or 1,000 minutes, it's going to be $30. So $30 and then 20 cents per minute. So that's why you're multiplying that 0.2 by m. 15, describe the transformation. And this is what I was talking about earlier. Describe the transformation. The negative is inside your parentheses, or in this case, your square root. If it's inside, first we know it's a reflection. Since it's inside, it's the y-axis. If it was outside, it would be the x-axis. Now, I've said this before. If you're not sure, always put if you're not sure, always put x-axis. And the reason is because obviously you'd get this one wrong if you did that. However, more often than not on a test or a quiz, you're going to do the x-axis is going to be the one we reflect. We do that a lot more than the y-axis. So if you have to guess, I would guess x-axis. But again, obviously, if you're guessing this one, you would have gotten wrong. Now, number 16, I'm going to give you a little hint with this one. This one will be multiple choice. So it says, what's the equation of the following graph? Well, since it's a U shape, I know it's x squared. Now the vertex, or this point here, doesn't go up, down, left, or right, so we know we don't have any +3 or whatever. You don't have any parentheses they do anything with. So we're starting with just x squared. We don't reflect it, so the only thing we did this one is, since these points are up here, we stretched it vertically. We kind of pulled that up. So normally those are down here at 1, 1. Now again, this is why I'm saying this, because I mean, we did one of these in class, I think, but these are difficult, and so I only put one on here, and I made it multiple choice. So if you're stretching it from 1, 1 and goes up to 1, 2, that means you're stretching everything. You're multiplying that y value by 2. So this y value was 1. Then it went up to 2. So since I multiplied that by 2, you're stretching it by 2. So your equation is simply 2 times x squared. Now, when I say simply, I mean it looks simple, but you have to make sure you're aware that it goes from 1, 1. You're multiplying that by 2 to get up there. If it would be multiplied by 3, then it'd be like if it would be up at, let me I'm trying not to make this video too long, but I do want to say this. If your point, instead of being here, would have been right here, then you'd multiply by 3 because it went from 1 up to 3. Technically, you do the same thing with the 2. 2 normally goes through 4, but since you're multiplying by 2, you can't see it, but this one would go through 8. So even if you don't use the 1, 1, if you use 2, 4, it's the same thing. And again, don't stress, there's only one question like that, and it is multiple choice. Number 17, put it in slope-intercept form. That means we're getting this y value all by itself. So we have 5x. Actually, I was just going to read. Don't need to do that. Maybe I should have. Now it's going to be a mess. So subtract the 5x from both sides. That cancels. So we have negative 3y is equal to negative 5x plus 18. Divide everything by negative 3. We end up with y is equal to negative 5 over negative 3 is positive 5 over 3. 18 divided by negative 3 is negative 6. Next one, put it in slope-intercept form. Now this is the one that I had a couple people say, will I ever make you put it in point-slope form and then put it in slope-intercept? Well, technically the answer is no, I'm not going to ever make you do that, but you will have a question like this where I give you point-slope form and you have to know how to put it in slope-intercept form. So again, there's maybe like one or two of these like this, but again, in my opinion, it's the easier way to do it. You just have to remember, take your denominator to the left, your numerator to the right. So we have 3y plus 12 is equal to negative 2x plus 24. Then go through and solve for y. So subtract 12. We have 3y is equal to negative 2x plus 12. Then divide everything by 3. So we get y is equal to negative 2 over 3x plus 4. Then number 19, again, these are one of those that hopefully doesn't take very long at this point. This should have been a fairly easy one in Algebra 1. My y-intercept is 4, so I put a point at 4. My slope is negative 3 over 2, so I always put it with the numerator. That means I go down 1, 2, 3, and over 1, 2 for my next point. That's all you really need. However, I know sometimes I do it up 3 over to the left just to get one on the other side. Sometimes I just do another one on the right-hand side. It doesn't matter. Again, you really only need 2 points. Sometimes I'm just, I guess, an overachiever. Rarely, but maybe sometimes. Number 20, write an equation for this line. So it's the opposite of number 19. So I know it's going to be slope-intercept form. So what's the y-intercept is positive 1. So that should be, hopefully, again, easy points if you remember. And then the slope. So it goes through this point. We know that. And it looks like this is the next point. It goes through really nicely. So you go down 1, 2, 3. So down means negative, and then to the right 1, 2. Now again, you could have done it the other way where I started at this point, and so you go up 3, so that's positive, and then to the left 2 is negative, so that's why those are the same. But that is why I always start with my left-hand point. I also will say that I apologize that 19 and 20 have the exact same slopes. I did not mean to do that, but it was kind of too late by the time I realized. Ah, sorry, it's touchy since I zoomed in. Number 21, graph the inequality. Again, there's a couple different ways to do this one. If I were you, I would solve it for x, especially if it's an inequality. I would not do the x and y intercepts because it's hard to tell where you shade with those. So for me, I will subtract 4x from both sides. I don't know what that is. Get out of there. So that cancels. We have negative 3y is greater than or equal to negative 4x plus 12. Then I divide everything by negative 3. Now remember, when you divide by negative, you still have to flip that sign. So now it is, oops, I almost messed it up as I was telling you. Y is less than or equal to positive 4 over 3x minus 4. So now my minus 4 is down here. I go up 1, 2, 3, 4 over 1, 2, 3. It is a solid line. Last but not least, y is less than, so we shade below this line. So that's how I would highly recommend doing it. You could find the x and y intercepts using the cover-up method. So if you cover this one up, you get your x-intercept to be positive 3. Then you cover the other one up, You get your y-intercept to be -4, but then again, the hard part is telling which side do you shade for that one. And so that's why with an inequality, I always use slope-intercept form. The next one's not as bad because it's already in slope-intercept form. So we have -1 and then up 2 over 1, 2 over 1. This one is a dotted line. And this one, y is greater than, so we shade above that line. I think number 21 is the one in my answer key where when I put these 2 points and I drew my line, I was just off. I didn't hit those 2 points very well, but it's hard to do white out on a graph, and so I just left it. I think I wrote a little note. 23 and 24, you're putting it in standard form. So the biggest thing to realize is standard form is your x comes first, then your y, and then your constant, the one that doesn't have any letters, is at the end. It's equal to that. But the other thing you have to realize, remember, no fractions, and your a has to be positive. So when you look at this one, the biggest thing that is you're going to have to change with this one is I'm going to have to get rid of my fractions. So since the denominator is 3, I'm going to multiply everything by 3. So that cancels. We have 3y is equal to, the 3's canceled, so we just have 2x, and then 3 times 4 is 12. Then now I can get my x to the other side, so subtract 2x. But again, you have to be careful because we're not quite done yet. Because we have the a in front with the x, that's great, but it can't be negative. A has to be positive. So again, you could multiply everything by -1 or divide everything by -1, but the easier way, in my opinion, to think about it is if I just change that to its positive, you can do that as long as you change every other sign in your equation. Even the 12 has to change. Now, number 24, again, there's a couple different ways to do this. So whatever way you want to do it is fine. If you don't know which way you like best, or if you're not sure of a different way, I would stick with this one. Same thing we've been doing, so distribute the 5 to the left. So 5y minus 15 is equal to 2x minus 30. And then same thing, we want no fractions, which is perfect. We don't have fractions. So we need to get the x and y on the same side. So the first thing I do, I'm going to add 15. So I have 5y is equal to 2x minus 15. Then I need to get the x on the other side, so just like the last one, negative 2x plus 5y is equal to negative 15. But again, we have a negative 2x, so to get the answer to this, I switch that answer, or that sign, which is the 5, and switches the 15. So again, not terrible, you just have to remember those rules. If you do it any other way than the way I just showed you, that's fine and you'll get the right answer. Just sometimes you might have some fractions where you're going to have to do what we did for 23. So whatever way you want to do it is fine. I just recommend point slope. Number 25, what's the equation for line A and B? So A is a horizontal line. So again, you just have to memorize. That's going to be y is equal to. Y is equal to what? Y is equal to 3, your y-intercept. Your vertical line is x is equal to, but x is equal to what? Your x-intercept is -2. So again, that's an example of one that it's not, I'm not going to say it's easy. I missed that a bunch when I was in high school, but you can study that. You could put that in your flashcards, and that doesn't take too much time if you know that. Find the x and y intercepts. So for my x-intercept, I'd take out my y. So we just have 2x is equal to 16. So divide both sides by 2. So my x-intercept is 8. And then for my y-intercept, I take out my 2x. Don't forget that negative still needs to stay with that. The negative still needs to stay with that 4 because now I'm dividing by negative, which makes my y-intercept, 16 divided by -4, is -4. So that is my y-intercept. 27, write the equation of line in point slope form that goes through the ordered pairs there. So the first thing you have to find the slope. So that's that y2 minus y1 over x2 minus x1. So x1, y1, x2, y2. So we end up with 2 minus -3 over 6 minus -4. you're solving these, that's plus, so that is 5 over 10. If you simplify that, that's 1/2. So that's the slope I use. Then point slope form, that means we have y minus -3 is equal to 1/2 times x minus -4, which again, when you have minus and negative, that is the same thing as plus. So please rewrite this, y plus 3 is equal to 1/2 times x plus 4. So that's one answer. The other answer is you could do the same thing just using this ordered pair. So y minus 2 is equal to 1/2 times x minus 6. Now again, for point slope form, those are the two different answers, but they're actually the same equation. If you would put those into standard form or slope intercept form, they would indeed both get you the same answer. Number 28, same story, it's point slope form, but now it's perpendicular. So remember, that's the opposite reciprocal. So the first thing I do is the slope I'm going to use is positive 5 over 8. I do that right away, and then I forget about this line completely, because all I needed that for was my slope. So then we have y minus 12 is equal to 5 over 8 times x minus -9. And just like the last one, just take out your minus negatives, x plus 9. So that's kind of nice, because if it wants it in point slope form, we can leave it like that. However, I think this other one wants it in slope intercept form. Now again, I'm going to do it that same way, where I start with point slope. This one is parallel. So again, the first thing I do, the slope I'm going to use is the same slope, -4 over 3. So I do point slope, y minus -2 is equal to -4 over 3 times x minus 6. But the difference, now we have to solve this. So take my 3, take my -4, so that's 3y plus 6, multiply those, -4x plus 24. Subtract by 6. 3y is equal to -4x plus 24 minus 6 is 18. I'm sure I could have done that in my head faster, but I do not trust myself, especially in the middle of a video. -4 over 3x, 18 divided by 3 is 6. So that is the way I would have done that one. Sorry, just making sure. But the other way to do it is, again, you could use slope-intercept form. So once we know our slope is -4 over 3, then multiply that by my x value, and my y value is -2. So when you multiply those together, again, -4 over 3 times 6 ends up being -8. If you don't know how I got that, and you don't know how to use a calculator, I would not do it that way. I would use point slope form. Add 8. That ends up giving you 6 is equal to b. So again, now we rewrite -4 over 3x. Again, the same slope we started with, plus 6, what we just found. Whoops, that should be a 6, not a b. All right, moving on to some of these transformations, and these are the ones I was talking about earlier, where these start going fairly quickly. Now again, I'm not saying that they're easy, it's just something that if you study for and if you know these rules, it's not too bad. Now technically the order matters, but the only one that I'm really going to be concerned about that is when I tell you that the order matters. So make sure you do look out for that one. But other than that, I don't mind too much. Technically, you start with the inside of the parentheses first and work your way to the outside. So technically, you should say to the right 3 and then up 7. This one doesn't matter the order at all. And again, these first 3 don't anyways because I didn't mention it. But the negative means it's reflected across the x-axis. And then the 3 is a stretch, a vertical stretch by a factor of 3. Sorry, that's really sloppy. Reflect across the x-axis, reflect across the x-axis, and vertical stretch by a factor of 3. So if you can't read that, hopefully that helped. The next one, so we have a weird f of x this time, but that's okay. We talked about this in class. It's still the same thing. 1/2 is in front, and so that is a vertical compression. And then by a factor of 1/2. So remember, the only difference between a stretch or a compression is if that number is bigger than 1 or smaller than 1. If it's bigger than 1, it's a stretch. So you just change, instead of the word stretch, you put compress, just like we did. But everything else is the same. It's still the same factor. The factor is whatever the number is in front. Even if the negative, remember that negative only depends on if it's a reflection. That doesn't make any difference on a stretch or compression. Now this one you need to do in order. So this one comes first, then this negative is second, and then the last thing is up and down. So we go right, 5, and then reflect across x-axis, and then up 10. Now these I should make sure I specify just in case you skip this. These are not fractions. I was just labeling what we do first, second, and third. Now the exact opposite. Now we're starting with the parent function, and now you need to write the equation. So we start, we have x squared. If you go to the right 2, that's inside, but remember it looks like it's opposite. So x minus 2. Don't forget the squared. I always forget that. You need that squared there. And up 8. Technically, if you have that, I'll give you credit. I would like you to have a y or an f of x is equal to, but even if you just have this, that's fine. But again, make sure you don't forget that squared there. A lot of people forget that exponent. So this one, x to the third, stretched by a factor of 2. So then we have x to the third, and then it's reflected across the x-axis. That means that is a negative. For each transformation listed below, start with the point -2, 8, and find out where it will be after the given transformation. So the first thing I do this in 2 steps. The first thing I do is I just ignore this, and I say what the transformation is. So this one is left 3, down 4. Now, if you want to get graph paper and actually do this and just put the ordered pairs or the new ordered pair, that's fine. That's not a bad idea. But now, once you have that listed, my second step is now I look at the ordered pair. So if you start with -2, 8. Now, if you remember, this was in section 2.4, I believe, and I gave you a separate little table for this. If you move it left, that means you're subtracting it from the x value. If you're moving to the right, you add it. If you're going up, you add it to the y value. Sorry, I think I maybe said that wrong. I wrote it down correctly. If you're going left to right, you add or subtract it to the x value. So left, you subtract it from the x. If you go right, you'd add it to the x. Up and down is the y value. So you'd add it if you go up. Since we're going down, we subtract. Now again, I know we said it looks opposite. That's when you're getting your transformation. So that's where this is a little confusing, and that's why I say break into 2 steps. Find your transformations, and then work with your ordered pair. So -2 minus 3 is -5. 8 minus 4 is +4, so we should have -5, 4. Now again, if I were you, I would not hesitate to check your work by getting graph paper and actually putting that ordered pair on there, and then moving it to the left 3 and down 4 and see what that ordered pair is. This one is 1/2. So for that 1/2, that is a vertical compress by a factor of 1/2. And again, hopefully you have this memorized if you have that little table. But what that little table says is that you take your ordered pair. If it's a compression or stretch, you multiply it by your y value. So if it was a stretch, you'd multiply that 8. Since it's a compression, same thing, you multiply that 8. 8 times 1/2, put it in your calculator if you need to, is 4. I mentioned when we did the lesson that I wasn't going to put that on your formula sheet. So far it's not. I haven't really decided, but definitely assume that it's not, because it's not as of right now. So it probably won't be. We'll see. graph the following. Again, you need these transformations, and the first thing I do is if it's to the third, that means it's going to look, that's not a good example. That means it's going to look like a little squiggle. Man, I can't do it on this touch screen. That's a little bit better. So we start at 0, 0. -3 is to the right, 2 is down. So we go over 1, 2, 3, and then down 1, 2. So that's my main point now. And then all I need, the only thing I'm grading is that point and the shape. So that is what we're looking for this one. This one is normally looks like this, but that negative means it's reflected across the y-axis. So it looks like this. That's the only thing. And then squared is a parabola. We are going to the right 3, and then it's reflected across the x. So go to the right, 1, 2, 3, but then it's reflected, so it opens downward. Now those are fine with there. Again, I'm only looking at the shape and that main point. If it's an absolute value, I'm going to be a little bit more particular because we did that extra lesson. So we did this, all this was on section 2.5. When we did 2.6, all we did was we honed in on absolute values. And so I am going to be a little bit more particular if it's an absolute value. So write the equation for this function. So it is an absolute value. So we have absolute value of x. We started at 0, 0 and went to the left, 1, 2, 3. So that means it's plus 3. Remember, it seems like it's opposite. We didn't go up or down any, so we didn't do anything left. And then it opens downward, so it's negative. And this is what I'm talking about. There's no stretch or compression, but remember, when we talked about absolute values, you can use slope. So we went down 1 over 1. So if you want to put that in there, but that just means your slope is -1, which is what we have there. Given this graph, and I put f of x or g of x, there's obviously just an f of x. Sketch the new graph. So the first thing I do is I just put my ordered pairs of my original. -2, 2, 3, 4, and then 5, -2. Then this one says, so I'm going to take that original f of x and I'm moving it to the left 2 and down 4. So every one of those ordered pairs I just put on there, the left 2, 1, 2, down 1, 2, 3, 4. And this one over 2, down 1, 2, 3, 4. And this one over 1, 2, down 1, 2, 3, 4. And once you have all those, now you can connect to the points. And again, it should look exactly like the shape we started, just to the left and down. Inequalities don't make these harder than it is. It's the same thing we did. So this one is going up 2 and it's reflected. So this is one of them that actually, when I think about it, the order does matter. So technically we should reflect it and then move it up 2. But I'm not going to be super nitpicky about that. So I just, honestly, with parabolas and with absolute values, I always think that negative just means it opens downward. So you go up 2 and it opens downward. And y is greater than, and so we shade above that. So again, technically, that means I went up 2 and then I reflected it. Oh, because technically if you would have done it the other way, went up 2 and then reflected it, it could have been, could be down here where it goes downward. So either one is going to be fine. I wasn't there to stress this and we didn't talk about it too much. So, but again, in my opinion, the absolute value and the quadratics, that negative in front just means it opens downward. So number 44, we go to the left 2, down 3. So from here we go left 1, 2, down 1, 2, 3. Then it doesn't open downward. The slope is 1, so up 1 over 1. So this, oh, and it's dotted. That was close. I always forget that on these, so I always label it. That way if I do forget, that's fine. It's dotted. Then again, y is less than, so we shade below this. If you're ever not sure what above or below means, always look at your vertex. Below the vertex or above the vertex, and that's going to tell you if it's inside your absolute value or parabola. So like for this other one, number 43, if you didn't know what was above or below, look at your vertex. Above the vertex is up here, so that means it's outside your parabola. Now we're going to the little bit of a deep dive into absolute values. So this is where we're going to have some stretches and compresses. But again, an absolute value, the only difference is that's a slope. So we go to the left 5, down 2. So 1, 2, 3, 4, 5, down 1, 2. Then from there, now my slope from here is 3. Now again, remember when I did it in the notes, I put slope, whoops, I spelled it correctly, but I put it in quotations because it's not actually the slope. It's only the slope to the right-hand side. So from that, I go up 1, 2, 3 over 1, 1, 2, 3 over 1. And then to get your other side, we just do that same thing, just the opposite. So instead of up and to the right, we go up and to the left. Or you can think of it as we're reflecting it across that axis of symmetry. So that's the other way to look at this. Sorry, I just found a mistake on my practice test. So if you're looking at the practice test, I accidentally went to the left 6 instead of 5. Other than that, everything looks fine. Well, with this problem, I should say. Then again, this is an inequality, so just be careful, but it doesn't mean a lot different. I go to the right 3 and then up 2. So right 1, 2, 3, up 2. So that's my vertex. Then my slope is -1/2. So again, the negative means it opens down, but you can use it with your slope. -1 over 2, so down 1 over 2. Down 1 over 2. And then again, do the opposite to the other side. Down 1 over 2 to the left. This is a dotted line. And then y is less than, which means we go under our vertex, which is inside our absolute value. And number 47, the last one, what's the equation for this graph? Again, our vertex is over here, so we went to the left 4, so that's +4. Then we went up 3, so +3, and then the only difference is now what's your slope. So our slope goes through this point. So go down 2 over 1, so -2 over 1, which is just -2. So y is equal to that whole thing. So again, the hardest part, really the biggest thing we learned when we did section 6 with absolute values is we learned that with a absolute value, the stretch or compression is just the slope. Now again, really this the slope of the right-hand side. Then the left-hand side, you can either reflect it across the axis of symmetry or do your slope the opposite. So if you're going up 1 over 2 to the right, we go up 1 over 2 to the left. Or we go down 2 over 3 to the right, so we go down 2 over 3 to the left. If you have any questions, don't hesitate to ask. Again, I know this is long, but that's 42 minutes. I know some of you guys are going to say, well, yeah, but you're the teacher, so obviously it's not going to take you very long. That's true, but remember, this 42 minutes was not me taking this. When I did this on my own, it probably took half that time, maybe less than that. But I explained every single step. A lot of these I did more than once. Some of these I did twice. So don't be intimidated by this. And again, the biggest thing is the more you study, the quicker this is going to go. And I know that sounds obvious, but especially for this one with transformations, going left, right, up, down, knowing when it's a vertical stretch or vertical compression and reflected across the X and Y. If you know those things really well, a lot of these problems go very, very quickly. Same thing, knowing that if it's a vertical line, it is X is equal to some number. If it's a horizontal line, it's Y is equal. Knowing all the information and studying that, knowing it really well, is going to make you go through this very quickly. So if you have any questions, make sure you let me know. Other than that, have a good one.